Okay, so with our flame test lab, so you guys have it in the journal. Remember, you are not turning in this page. You are turning in pictures of your journal onto Schoology when it's ready, right? Or you're emailing me the pictures. Or you're having a friend email me the pictures, whichever. All right, but you guys had that background info. You guys, most of you were able to get your stamp for putting your name, date, title, purpose, or objective. If you did not do that and you didn't get a stamp and it's still not done, you need to start with that today for sure, okay? So you should have your name, date, title, purpose, and the objective statement. So that's this statement right here, okay? And then your pre-lab, this is the part that you're going to have to add in. Oh, you guys should also be able to sketch your setup now. So with the procedure section, you got to see what it was. If you need to look through the window next door, I can ask him for the key. We can go look if you need to see it again. Okay, but you should be able to sketch your setup. I don't need super big details, just what did it look like, right? As well as what safety rules did we have to follow. So you guys should be able to do that one now. Okay. Then going back down here, the pre-lab questions consisted of, so if you have your pre-lab in front of you, check to see, do you have all 4 of those definitions? Remember, you could have looked on Google. I can go grab you a textbook if you need that, or use your notes, okay? All right, then you had to, once you had 4 definitions, then you had to flip it over, and you had to be in the data table. You had to write in things into these first 3 columns using a periodic table, right? So I kind of already went over that on day 1. So if you need help with that today, make sure you let me know. You already know that at the stations yesterday, all of these first things were listed, right? Those were the metals that were being tested. That was the whole point of the lab. We weren't testing the chlorine, we were testing the metals, right? And so that's why the ions were the only thing that I wrote on the tables, okay? So once you had that, you were able to figure out atomic number, what row it was in, and then what column it was in, right? Okay, so then you had that. Then you go back to your pre-lab questions. Number 3 said, how does an electron move from its ground state to an excited state? So we just had that in the booklet. What did it have to do? How did it move from ground to excited in our lab? It absorbed energy. Good. So absorbed energy. Okay. And how did it specifically do that? We heated it up, right? So we gave it heat. So yours has to be in a complete sentence, just so you know. So don't just write that in your journal. All right. I'm just giving you some hints. Then, when did we see the color? When it what? When energy dropped, maybe the electron dropped, right? So this took it to excited state. This one, when it came back to ground state. So when it dropped back to ground state. It emitted the energy that it just absorbed, right? And what's kind of neat about that, if you think about it, okay, is that it absorbed a certain type of energy and it gave it back to us as visible. So think about, with that whole electromagnetic spectrum, it shifted where it was, right? So it's kind of neat to think of it that way too. All right, number 4, it says, is energy directly is energy directly related to wavelength or directly related to frequency? Is going to be the frequency, so make sure you wrote that. Okay, then you had to, for number 5, you had to color your visible spectrum. Okay, so you had to get your color pencils. I have some up front. You want to make sure this is colored in, because what you did, most of you who did end up coloring it, you blended colors, and that was good. That was what I intended. Does anybody have it so I can show the next step real quick? Thank you. You had to add the rest of your electromagnetic spectrum in there just so that you knew where it's going to go. So once you had your colors like that, then you were able to get your data yesterday. So yesterday, you guys did this whole column. You got colors and you wrote them in. And I kind of told you, hey, make sure you're pretty specific with your colors. And I think I told you guys at the end, so sorry. So if you need to check some of your colors with mine, you can do that. But you have those colors there. Now that you have them there, you're looking up at the spectrum up here, okay? So we had yellow here. So this one was like a yellow-greenish. Some people put gold. That's fine. So you're kind of right about here. You're kind of in between those, right? So What we can put for that, if you interpret it as yellow, you can definitely put the 600, but feel free to put 575, right? So that's the whole point of blending the colors, is that if you think it was an in-between color, then make sure your number indicates that. So this is the part that you should have already done, but if you didn't, make sure you fill in what wavelength it matches up to. That was the point of coloring this. Does everybody see that? Yes? Okay, perfect. All right, so back to mine, and I'll just kind of cover up those in case you don't need them necessarily. Although some of you guys who didn't finish, if you need some colors or help with what color it was, you can use some of those. But I will just continue on with strontium because that was the one that I had started. So down here, I got like a pinkish red. So when I looked at my color spectrum up here, I put it as 675. So kind of in between the orange and red. Once I had that, now today we can start the post-lab section, right? So that part was all yesterday. You should have gotten all that data, right? So now the post-lab, you're filling out these 3 columns, and it's really not too bad. I only need to see work for at least one of your calculations, and then feel free to just plug and chug into your calculator, all right? Work with your group on that. Okay, so I'm going to show you how to get this next column, okay? When you are converting between your wavelength that you grabbed from up here, so I had 675, all that you're doing is you're going to divide it by 1E9. So looking down here, it says find the approximate wavelength. That was the part that we did yesterday, or you're going to do it right now. And then you're going to convert it to meters. Why do we have to convert it to meters again? Anybody remember? What's so important about it being in meters instead of nano? What's the speed of light unit? Anybody know? It's the one that's 3E8. You guys should all have a periodic table, probably from the front. So look at your periodic table. Go grab one. Let's go. You guys got to know how to do this. So you flipped it over to the back. You have speed of light right here. 3 times 10 to the 8th. 3E8 meters over second. So you guys see that? Meters per second. So the fact that it's in meters, that's why we can't leave it in nanometers. That is not in NM. We have to have it in just in M. Okay? You have to convert it. So that's the whole reason. Because we use these nice little formulas that you got to practice in the warm-up yesterday. Okay? You use those in order to solve for whatever missing information that you have. Okay? All right. So once you have that column with your nanometers, you're just dividing it by 1E9 to get the next column. Okay, so when I did that, I got 6.75 E negative 7. Okay. And so I'm just going to write that in there. Then, so what I would do is run through all your calculations. So at least show your work again for just one of them. Okay, so pick which metal you're doing it for. Show me all the work for it for these next 3 columns. And then the rest of the way, you can just plug and chug into your calculator. Okay? All right, so once we have that, the next one says, use your speed of light formula, okay, or use the speed of light to calculate the frequency. So if that's our formula right there, C equals wavelength times frequency. Remember, I showed you guys your little algebra triangle yesterday. I reminded you of it. Okay, so if I'm solving for frequency, remember you cover up the F, and whatever you're left with is what you're plugging into. So F is equal to speed of light divided by that wavelength that you just got, right? So frequency is speed of light divided by wavelength. So I am just showing this setup, okay? So that's all that I'm doing. I did my speed of light divided by my wavelength. Okay. So that is to get your frequency. Okay, once you get your frequency, then you're doing number 4. So number 4 says, use frequency in Planck's constant, and there's Planck's constant right there. I'm okay with you changing that to 6.63 to match up with your table, or your periodic table number. But you're going to do Planck's constant to calculate energy of light. So we're going to be using E equals Planck's constant times that frequency that you just found. Okay? So your answer from number 3. So once you have that ready to go, you're plugging in that frequency, you're multiplying it by Planck's constant, and there's your energy. Okay? So this right here, this is the process that you're doing. Once again, how many do I need you guys to show me it for? What? Just one. Just one element. Pick one element. You're going to do that. You're going to show me all the work for all those calculations all the way across your table. Okay? So if you really, 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 really are feeling lazy, feel free to use my strontium. I got you started on it, right? And then you just have to do the rest for the table. You don't have to show me the work for it. You just got to get your answers into your table. All right, so that's how you're going to get your energy. Okay? All right, then number 5 says, according to the energy emitted, what was your unknown compound? I will do that with you guys on Monday, so don't worry about that. It doesn't need to be in your lab report. Leave that whole line blank. We'll add it on Monday. Okay? So don't worry about doing anything with number 5. Okay, number 6 and 7. So number 6 says, why should dry sodium chloride, sodium nitrate, sodium acetate reveal the same color? You should be able to answer that. Work with your group on that one. Just answer it. Number 7, for the metals in the same family, you're going to answer that one as well. It's part of your conclusion. Okay? Okay. And then you have number 8 over on the other side of this page real quick. And you should be able to knock those out pretty quick. I am okay with you not putting your frequency line. If you just want to keep it straightforward, put your wavelength with your energy, because those are the most important. Okay? Frequency is the bridge, so who cares? Remember, your shortest wavelength is your highest energy. Your longer wavelength is your lower energy. And then you should be able to answer them. So that's it. So do you guys have any questions over anything that I just went over?